thank you for joining. I would like to share with you the story today of how we designed the new order monitoring system at Porsche and take you a bit on the journey with me from the development of this project, from nightly data loads to an event-driven analytical system for real-time insights. The presentation is basically split in two parts. After giving you some insights about the context of the project, I would like to share with you some information, some insights about our journey. So basically how we analyzed the user's problem, the customer's challenges, and how we came then to a solution architecture. And then of course, the second part where I want to go a bit deeper into the solution architecture and share with you some insights on how we realized this architecture with the help of AWS technologies. And to jump right in, this is basically the challenge situation on the customer side summarized in one sentence. And this is a sample for this particular industry and for this particular business process that we are targeting. But it can be adapted basically to any other industry or something. You will have similar challenges everywhere in the industry. Doesn't matter if it's now sales reporting, order management, or any other HR analytics or something. In the end, it's all about getting insights into your processes, into your data to make sound and precise decisions. And you need to have these insights on time. It doesn't help if you have the insights 3 days later after something happened, basically. So this is actually the leading goal that we have throughout the whole project. To give you to frame a bit the situation. The specific success story I'm talking about is set at the Porsche AG. We are in the context of the order management process, which is one of the core processes that Porsche has, managing customer orders, managing sales and delivery. And MHP has been joining Porsche here for several years now, and together we've been building a new order management system based on a new cloud-native architecture, as you would have built it today, like decoupled, event-driven, so all the boxes basically ticked regarding modern architecture and modern cloud-native solutions, and of course on AWS. And this is where we come into the space of order and sales reporting, which is a crucial part of this order management process, because the process involves basically the whole market organization. So everything from Porsche market side towards importers, dealerships. In the end, everyone has to work with the system and has to make certain decisions on how to put sales, how to organize shipments and stuff. So what's basically crucial for all the users we have is they need to have precise insights and they need to have them on time in order to make good decisions and make them at the right point in time and not too late, because then it's over. And the second challenge, it always sounds a bit negative if you talk about data fragmentation, but it's totally not meant in a negative way here. Because the overall system we're building for the order management is basically an event-driven, loosely coupled, distributed system where every part of data is basically owned by a certain part of the system, and then it all comes together. But if you look at the overall domain, you have a lot of different data sources that you need to put together in order to get the full picture of your process in the end. So this just means for us, in an architectural perspective, the challenge, if you look into your system's context, you have a lot of connections to a lot of different systems, but you can't track basically for every system what portion of data comes from that system, and it has always only one source. And of course, because we're targeting here the full market organization, you have a lot of users worldwide, very distributed in different time zones, in different locations that you need to target with this system. So this also means you need to scale globally, basically. At the beginning of the project, and this is somewhere in beginning of last year when we started basically the work on this order monitoring project, is we set some very basic goals. And this is the first one is basically the distilled summary of the Porsche data strategy. It is in the core the idea of data mesh, and it means for every portion of data you enable a single source of truth So you can track down where every data comes from, and it only has one origin. And we also want to apply this for analytical data. I mean, for transactional data, it's usually pretty clear, but for analytical data, it's usually not that clear because analytics is usually based on the transactional data, on aggregations of it, but most of the time, it is recomputed in every different analytical system, so you're always just accessing the source data and then recomputing it. So this is what we wanted to change dramatically. Yeah, of course, enable real-time insights. I already said that. That's the crucial part for our markets organization, for the decision makers in the end. And then, of course, scale it cloud native on AWS. That was a set goal because the system itself is built on AWS, and we also wanted to have the analytics system as closely coupled to the other system parts as possible to integrate it tightly into that. And then, of course, as said, we need to scale globally. So we're talking about pretty huge amounts of data that we're getting every day, and we need to have the possibilities to scale that. Now, when we started the project, and this is basically, as said, beginning of last year, the first times we talked about what the analytical system should look like, we took one step back and said, before we now start, and usually if you talk about analytics, you start collecting data and then later on try to find out what to do with it and what analytics you can draw from it. But we said, no, we want to build a different system here. We want to basically first understand what challenges our users are actually facing. So what decisions do they need to make? What insights do they need to make these decisions? What data do they need to see at what point in their process? So we took one step back and said, okay, we're gonna approach the problem space first. And this is, MHP has a flavor of, I would say, flavor of design thinking, how we tackle these kind of situations. We call it triple diamond. That's basically our universal approach on how to process such a challenge. It basically boils, in the end, it boils down to first, you need to understand what the problem actually is. You need to understand your users, your target audience, your surrounding systems. And if you have a sound understanding of all these circumstances, then you can start actually solving these issues and making basically solution hypotheses that you map then towards your requirements in order to always validate whether what you actually design matches the requirements. And this is what we applied for our actual architectural process. And that in detail looks like these 4 steps basically. First, when we kicked it off, we started on some architectural level, setting some rough guardrails, like what should be boundary conditions for the system. We decided to go for AWS. We also decided to not go for a traditional warehousing approach, but we actually said we want to design a analytical system that is more a domain-specific small system that integrates with other parts, but which is not built on a big platform solution. And then we started digging into detail. And we involved all the stakeholders. We made a series of workshops to basically derive the business requirements. We used several methodologies from the UX space for that, like setting up user journeys, gathering requirements in form of use cases, and also continuously validating our ideas and our understanding of the actual business side. And then what we did in parallel is also we analyzed from the technical side the problem space. We analyzed the customer's data strategy, the overall IT strategy, what are the big words currently in the technology world, like what are the trends and where do system design lead to currently. And this all converged then in a design of building blocks, and I'm going to show that to you in a minute, which basically solve these issues. And the building blocks is a set of unique capabilities of the system. It is an open kind of architecture, so you have certain building blocks and you don't need to have them, or you can have them in different flavors. And every one of them brings certain capabilities, which you can then map to your requirements in order to kind of validate it's actually what you need. And then, of course, something like interfaces to other systems as well. And now we are in the fourth phase where we started implementing the solution, and we're continuously evolving the architecture and the overall implementation, the solution idea of it, continuously validating that with user testing and trying to involve as many stakeholders as possible, because in the end we don't want to throw solutions at problems, but we actually want to understand the problem first and then build a solution exactly for this problem, rather than saying, I have a hammer, I put it on everything. Now, I only have limited time, so if you want to know a bit more about the process and how we undertook that in detail, how that went with our stakeholders, we published an article in our Industry 4.0 barometer this year. You can download that under that link, or if you prefer reading on paper, we also got print versions of it. You can, over there is our booth, you can just join us. My colleagues are very happy to help you with that. And there is also a ton of other studies and interesting cases in this publication, so check it out. Now, let's lead this over to how does the actual solution look like. And this is also where I want to start on a very high level and then zoom into details. So we start on the very outest level. This is the data mesh. It is basically representing in the end the whole company from a data side. If you're familiar with the data mesh, I'm not talking very new stuff here, but what is it about? It's basically one side an architectural pattern for distributed data architecture, but on the other side, the data mesh itself, the idea of it, also defines an organizational structure. Because in the end, what it comes down to is it emphasizes or it defines data products and emphasizes ownership over these data products. A data product in itself is a portion of data that has in itself a certain meaning, like for example an order or an appointment. And you have one system of record, one single source of truth where this information comes from. And instead of then copying this data around, you make it available to other users in your whole organization. And you have then like a catalog. This is what the federated data governance then basically comes to, where you can discover this data, and if you have a specific use case, you can then basically collect the data from these different sources, and you always have a clear responsibility for this portion of data. And if we now go back to our use case and zoom a bit more into our domain where we implemented this order monitoring, so the orders domain, you see also there, this is not a single big system, a single big database where all our order data resides in, but also inside of this order management, we have different subdomains. The system is subdivided into individual parts, where we, for example, have one thing like that takes care of orders, and one thing that takes care of appointments. And we have the order monitoring, which is actually our analytical data. And every of these icons represents a certain data product, which we share with the whole organization, and for which one we also take ownership. And now what is a bit different when you think about analytical data is never a first source data, so to say. It always is basically a derivation of transactional data. You will never have somewhat like an order intake per month figure that stands on its own. It represents a certain set of events that happened in the actual transactional system. So that is what we also said, but we want to keep this data in the same manner. We want to handle it in the same way as it would be transactional data. So we apply the same methodologies here. And what we share inside of the data mesh, and that's basically these two icons over there, is we share two flavors of this data. One is the historic data, where we say, okay, we want to enable comparisons to past data, and we want to enable our users to analyze historic data to see how last year went, how many things were built into our cars the last few years or something. But there is also another stream, which is basically fast-moving data, which means in the end this is an event stream, technically spoken, where every system, if it has a change, it publishes this change to an event stream. And then a customer can subscribe to this event stream, select which of the events he's actually interested in. So the publishing system doesn't care about what the consumer needs and what not. So it publishes its changes, and then the the consumer can decide whether this is relevant for him or not. But we don't make one-to-one connections in this case. So we just say, okay, we make this data available, and then we enable every consumer basically to use it. And for our use case, the event stream is basically the one we targeted first, because we said that the crucial thing we need to build is this real-time insights, but still we also implemented the historic part of it for other use cases then. And for the historic part now, how can we solve that with AWS technologies as well? And this is again a simplified view because the detailed architecture is like, I don't know, 20 times more complicated. How can we adhere to this idea of a single source of truth and not copying around data to all the places, but still make it available and analyze it? And this is what AWS has very great functionality in the last few years added when it comes to basically building data lakes, like lake formation. And in the end, what it comes down to is you have a distributed data catalog where you register your data sources, where you register your data products, and then you can make them available to other systems. And this is here the kind of illustrated. We have data from other domains which reside in that domain. You don't need to copy all the data over to your system, but you can make it available in a linked way where you can analyze it. And this is where we are using Redshift Spectrum. The same works with Athena or something, where you can, in your database, have remote tables that look like you can handle them, you can use them as if they were local tables, but they're actually coming from somewhere totally different. And the big benefit of that is it always is one single truth, because you're not accessing last day's copy of the data, you're accessing the actual data in the other system. Maybe there is a layer in between for access or something, but you access the data in the fashion that someone who took ownership for it actually publishes it and wants to make it available for you. So you're always talking about the same state of the data, and you can track that down. This is about historic, and now the primary part we're looking in with the project currently is the real-time insights, how to enable this. And if you look into a traditional analytical system, usually what you have is on your left side you have the source system, then you have some sort of ETL processes that pull out batches of the data from the sources. You have heavyweight data processing, you have your analytical data model, and then in the end it all comes down to reports that you share with your users where they actually can see insights on the data and which is the actual valuable thing to them. They don't care about the middle part of it. And this doesn't change much when you think about an event-driven communication instead of an ETL procedure. What changes is basically you don't get single big batches, but you get a continuous stream. And this is the basically difference in your thinking that you need to make, because you don't have daily updates or daily states of a data, but the state of the data is a continuous flow, basically, a continuous stream of changes. And what this helps us with is there is no gaps in between. You always have the latest changes from your transactional operational system, and you don't have the gap of a full day where something happened in the system, and now in your analytical thing, you have to again find out what happened in between actually. But you can track down every change, so maybe a single change only changes one figure in a dashboard, and you only need to update this one figure now and not the full reporting. And it also helps with balancing load a lot, because this continuous flow over the day means you don't need the processing power for analytics once a day when you get your big ETL load and then basically your CPU is cooked, but you get it throughout the whole day. And this is also where the serverless technologies of AWS help you a lot with the scaling and with this continuous flow of information. Now, how does it actually look like on an architecture perspective? So what the core part is, how we designed the system around this event stream, is basically we decoupled the KPIs itself, which we now see as data products, from the actual reporting, so from the users, which means the system itself doesn't care about its users actually, how they want to access the data. We offer, of course, built into our system, we offer a part where we have a standardized reporting set, where we have a very high density of data in custom UI that's tightly integrated into the order management system. But in theory, or in practice also, this is only one way to access the data. But we're also offering, as we get the data from the event stream, we also push our analytical data products back into the data, into the data mesh, basically into the event stream, and then someone else can handle something. So for example, the business logic that determines an order intake, and this sounds simple, but if you're thinking about a globally distributed system over different time zones, then already the time dimension is pretty complex on when to count for an order intake and when not, depending on where the order comes from, which market you're looking into, and so. And so this portion is already a valuable thing for a consumer. Already, so even if it's not aggregated yet. So we also stream out this information because we say we are the owners of what makes up an order intake or a retail. And then if a follow-up system wants to trigger something, and this is what users usually do, they trigger follow-up processes based on something happening. They have the possibility to connect to this stream. They don't need to know how the business logic for a retail looks like, they just get it. They just get an event, a retail has happened. And they can then derive whatever they want from it. And if we look into how that looks like, and now the clicker, click, yes. How does it look on an AWS perspective? So our basic data processing, this is serverless. So most of it is actually serverless, or actually everything, apart from a bit of networking. Our event processing is mostly done in Lambdas, actually, which are, for our experience, they are very fast. They are scaling a lot when we have big data loads. We're using Kafka basically as an event stream. For the data storage, we're using Redshift, also serverless Redshift. And on top of that, of course, the usual services for providing UIs worldwide and APIs. And this is basically how we realized that system. It is not it is basically, in the end, it boils down to we have a pretty specific analytical system, which is in itself domain specific, but the overall architecture can be provided to any other use case or to any other domain as well. And in the end, the core idea of is, if you look at the data mesh, is have multiple of these systems, everyone in their own domain, basically only taking care of the information of this very domain, interconnected via the data mesh and event streams. And then you have this idea of a distributed analytical system also closely to your actual transactional systems in the same way they operate with each other. And now if we look into the results of this one, so what we achieved with this project is basically we showed that handling analytical data can be done in the very same fashion as traditional transactional data. So it can be done by a similar system. We can still have one single source of truth, so we don't need to copy around source data, but we have this one single source of truth also for analytical data and its products. What is very crucial for us is we need to have these KPI calculations and insights in pretty much real time. So that was one system test we did, is between the action happening in the operational order management system and a KPI updating on user side took us about 5 seconds. So this is also pretty impressive how AWS scales in that regard. So even though we're pushing multiple thousands of messages through that system a day, it still scales and remains fast. And then, yeah, of course, what we also did is for our customer, when we started after the architectural phase, the implementation, we also decided to do that in an agile manner, that we're shipping first valuable parts of the system very early. And this is basically coming down to this idea of decoupling this whole system into things that are in itself valuable. Like, for example, if you implement the business logic part for a certain KPI, that's already providing value to the customer. You don't need to build up a big warehouse where you first ramp up servers, then collect a lot of data, and then build your data model from ground to top. But you can pretty quickly actually deliver value to the customer. And it took us 3 months to deliver the first KPIs with that architecture. So that was pretty good for our customers, so that they could quickly also see we are providing value with this one. And yeah, the other stuff is, currently we're at 12 data products, but that slide is a bit outdated. Yesterday was our sprint change, so might be 15 now. And yeah, of course, AWS does a great job in scaling here and providing us the availability that we need for our users worldwide. And that's basically everything said. If you got any questions or want to discuss something or have ideas or whatever else, you can just come over to our booth straight over there. Will be happy and my colleagues to answer all your questions and discuss with you. And yeah, that's it. Thanks for listening. Have a great day and thanks for joining.